You need to be fully confident in these things when dealing with binomial distributions. Part A. State the 4 things required for a variable to be modeled using a binomial distribution. It helps to write a general distribution model and then see the 4 conditions from that. So if we write that x is binomially distributed with n and p, we can see that we need a fixed n value, a fixed p value, 2 possible outcomes because it's binomial, and that the trials are independent of each other. A user is at a theme park and wants to win a giant banana plushie from the ring toss. The chance of him successfully tossing a ring on a single throw is 0.6. Part B. He pays for 5 throws. Assuming each throw is independent, find the probability that 2 rings land on the bottles. So let's write down my variable first. X is going to be the number of successful throws in 5 tosses. So this means that x is binomially distributed, my n value is 5, and my p value is 0.6. Part 1. Find the probability that 2 rings land on the bottles. That's just the probability that x is equal to 2. So in my calculator, I go into distribution mode, binomial PD, then in variable, I put in x equals 2, n equals 5, and p is 0.6, and I get 0.2304. Part 2. The probability that fewer than 3 rings land on the bottles. So that means I want px is less than 3. When using binomial CD, a cumulative distribution, we need a less than or equals to sign. So here, if I've got something that's less than 3, the highest value it can be is 2. So this is the same as the probability that x is less than or equal to 2. So using the calculator, but binomial CD, if I put in the same values, I get 0.31744. Part C. To win, he needs to score at least 3 points. What's the probability that he wins the plushie? So for part C, I need the probability of x to be greater than or equal to 3 because it's at least 3 points. Remember, I need to have less than or equals to. So this can be written as 1 minus the probability that x is less than or equal to 2, because those are the remaining values that we don't want, and all probabilities add to 1, so you'd subtract that. So that is equal to 1 minus this value here, 0.31744, which is equal to 0.68256. And that is the answer to this binomial distribution question.